Conductivity is a measure of water's ability to carry an electrical current. Here on the banks of Birch River in West Virginia's Webster County, biologist Ben Faulkner shows students the science behind conductivity.
I'm Ben Faulkner, and today we want to teach you the truth about stuff in water. You know, we all need and expect clean water, but water in streams is complicated, and sadly there are some people right now that are telling us that mining pollutes our streams. Well, I'm a stream scientist, and the most important thing that scientists do is search for the truth. Okay? And we'll have some fun today while we examine some of the stuff that's in water. You know, perfectly pure water has some interesting characteristics. It doesn't conduct electricity.
Distilled water measures at about 8 microsiemens per unit of conductivity. Rubbing alcohol has even less. It has a conductance of 0.
So I'm saying just because something has a 0 conductance or a low conductance doesn't mean it's healthy to drink. Okay? That's the important thing.
Faulkner explains why the same theory applies to liquids with a high conductivity. His measurement of the Birch River, which drains from a mine site, is 154 to 138. He says many of the expensive spring waters we buy test much higher than that.
The water from Fuji in the Pacific has a conductance of 267, so it would just barely pass. If we went to France and got water from Evian, the conductance is already higher than the EPA standard at 558. Perrier has 712, and expensive water from Italy has a conductance of 1139 microsiemens. Think apple juice has got a high conductance, 1919, and good old Gatorade, 2580. Some of the things that might be in the water from a mine site might be iron. You might have some zinc, you might have copper, selenium. By the way, where did I get these? What are these? They're vitamins. So don't let people tell you that iron and zinc are toxic chemicals, because you got to have them. If you don't have them in your body and you don't take a vitamin, you get sick. The concentration is what's important, okay? And when we find these things in the stream that are in high concentrations, we mine in such a way to limit the amount of metals that get in the water. Not all dissolved things are a problem. Many are natural, some are necessary for life, and the amount is important.
The Environmental Protection Agency has identified a benchmark of 300 microsiemens per centimeter for unacceptable levels of conductivity. Faces of coal and scientists like Faulkner believe conductance is too broad to measure the quality of a stream.
It's just a poor way to evaluate whether the stream is healthy or not. It's a much bigger issue than that. We need to take, good chemistry, do analytical work, and see what's here and regulate that just like we always have. We don't need this all-encompassing, simple standard of specific conductance to indicate whether we should or should stop mining in a watershed. It's a departure in the wrong direction. It's a departure from good science. It's important, no matter what you do, to look for the truth. And the truth really is that specific conductance is not a proper parameter to evaluate stream health.